Video, try it yourself, and then push play and watch me do it, okay? So go ahead and pause it now. All right, now that you've paused the video and tried the example yourself, let's do it together. 706,000. Well, here, notice we have a 0, and earlier I said zeros are placeholders, right? Well, not if it's between two other other digits that are non-zero. So for example, here we have a 7 and a 6, and between them we have a 0, so that 0 is also significant. So our sig figs here are 706, and we place our decimal after the first digit. And now we're going to multiply that times 10 raised to the something power. Well, how many did we move over to get to our new decimal point? Let's look from here. 1, 2, 3, 4, 5. So rate 10 to the 5th. 7.06 times 10 to the 5th. And that's all the work you need to show. Eventually, you might not have to do the bumps, but for now, go ahead and do the bumps to get over and find how big your exponent is going to be on your 10. And then you simply just bring down your significant figures and add the decimal after the first digit. That's how simple it is. So that's going from standard notation to scientific notation, which, by the way, I wrote here as just SN. That's scientific notation. Now, what if they give us scientific notation and we need to go to standard notation? It's the same process, we just go the other way. So this is 5.14 times 10 to the 10th. Well, let's write our significant figures. 514. Okay. And our decimal was after the 5. So now we're going to move it. Which way do you think? Think about it yourself. I know I'm asking for participation and you're on the other side of a computer, so I realize it's very stupid, but I'm already 8 minutes into a video and I don't want to start it over. So anyways, 5, we're going to have our decimal right here between the 5 and the 1, so we're going to move it 10 places to the right. 1, 2, and then how many more? 8. So instead of going, 1, 2, 3, 4, 5, 6, 7, 8, and adding all those zeros, you can just look at it as 5, 1, 4, 1, 2, and 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So 5.14 times 10 to the 10th gives you this number. It's pretty big. All right, so that's it for positive exponents. What about when a number is really small? This is obviously a big number. What about when a number is very small? Well, before we start talking about scientific notation for that, I want you to go ahead and fill in the missing terms in this list. So go ahead and write this list and fill in the missing terms. Pause your video, write the list, and fill in the missing terms. All right, now that you've paused the video, or played the video again, I'm going to go ahead and walk you through these terms. So 32 to 16, well, what do we do here? We divide it by 2, and you see that it does that every single time. So 32 divided by 2 is 16, 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1, 1 divided by 2 is 1/2, 1/2 divided by 2 is 1/4, divided by 2 is 1/8, and then 1/16. All right, and what was happening here? We were simply subtracting 1. 5 minus 1 is 4, 3, 2, and this is going to be 1, 0, -1, -2, -3, and -4. So the significance of this is simply to show you the way, well, I'll go ahead and show you right now. 32 and 5, there's a relationship between these two numbers. I'm going to scratch this out just so you don't pay attention to it. 2 raised to the 5th is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so 2 raised to the 5th is 32. Here, 2 raised to the 4th is 16. 2 cubed is 8. 2 squared is 2. 2 to the 1st is 1. You're seeing where all these numbers are coming from, right? So 2 to the 1st is 2. And then we're getting our exponents from this list right here. 5, 4, 3, 2, 1, 0, negative. So what's our next exponent going to be? 2 to the 0, which is 1. Anything raised to the 0 is 1. Okay? 2 to the -1 is 1/2. 2 to the -2 is 1/4, 2 to the negative 3 is 1/8, and 2 to the negative 4 is 1/16. And so all this is showing you is the relationship between an exponent and the form that the number results in. So for example, when we have a positive exponent, like 2 to the 5th, we're going to have a whole number. But once we get all the way down to a negative exponent, it starts resulting in a fraction, okay? So 2 to the negative 4th is 1/16. You notice that's a fraction. It's 1 over 2 to the 4th, as we discussed earlier. So to put that in general terms, a negative exponent is written as n to the negative x equals 1 over n to the x, and n being any number, x being any exponent. So go ahead and pause the video and try these 3 examples on the right. Now that you've tried the examples, I'm going to go ahead and do them for you. 5 to the negative 2, well, that's simply 1 over 5 squared, which is 1/25. 6 to the negative 1 is simply 1 over 6 to the 1,